Next chapter we are going to see thermodynamics numericals. So exercises page 108. We have number 4. A gas contained in a cylinder fitted with a frictionless piston expands against a constant external pressure. They have been given to us in the question. The pressure is given to us of 1 atm. So I have already explained 1 atm. It will be 1.013 into 10 raised to 5 Pascal. This is the pressure given to us. Volume of 5 liters again. So volume is 5 liters. So this will be 5 into 10 raised to minus 3 meter cube. Convert liter to meter. Okay, from a volume of 5 liter to volume of 10 liters. Okay, initial volume is 5 liter, final volume is 10 liter. Sorry, 10 liter. So this will be 10 into 10 raised to minus 3 meter cube. So what will be the change in volume? dV will be the change in volume, that is V2 minus V1. That is 10 minus 5, or I'll take 10 to the power minus 3 common. So this will be 5 into 10 raised to minus 3 meter. Change in volume. Determine the change in internal energy. If it, in doing so, it absorbs 400 joule of thermal energy. The heat absorbed by the system, the heat absorbed from the surrounding by the system is given as 400, right? So they have been already given. Heat Q is given as 500 joule. And what is the internal energy of the system? So you know first law of thermodynamics. dq equal to du plus dw. This is the first law of thermodynamics. dq equal to du plus, so du will be equal to dq minus dw. So du will be equal to dq is 400 minus dw. dw you will have to convert that. Yeah, dw will be pressure into change in volume. Yeah, dw will be, you'll have to convert the formula. dw will be work done is pressure into volume to pressure into volume, pdv. So du equal to 400 minus pressure 1.013 into 10 raised to 5 into change in volume 5 into 10 raised to minus 3. So when you solve this, you get du equal to 400 minus the number on the right hand side, 400 minus the term which you get on after the minus is a greater number. I guess it is something 525 if I'm not wrong. Yeah, it is 506.92. It is 506.92 joule when you solve. So the answer will be negative minus 106.92. 400 minus 506.92. 506.92 is the bracket term which I have multiplied. 1.013 into 10 raised to 5 into 5 into 10 raised to minus 3. When you solve this, you get 506.92. When you subtract, you get the answer in negative. du equal to minus 106.92. This is a previous year question. This is a very important, very easy previous year question. They have been asked for 2 marks. It is so easy for 2 marks. A system releases 125 kilojoule of heat. So dq is given 125 kilojoule of heat and 109 kilojoule of work is done. So dw is 109 kilojoule. You have to suppose to find the change in internal energy again using first law of thermodynamics. So what is the first law of thermodynamics? First law of thermodynamics is dq equal to du plus dw. So du will be equal to, first rearrange, then put the value, dq minus dw. So 125 kilojoule minus 109 kilojoule, that is 21 kilojoule. That's it. Only you have to minus the two values given to you. This is a previous year question. This is already asked in board exam. The efficiency of a Carnot cycle is already given to you as 75%. Efficiency of a Carnot engine or Carnot cycle is given 75%. So I can write this as 75 divided by 100. 75%, I can write this as 75 divided by 100, right? Then or I can say 0.75. I guess that will be better to write 0.75. If the temperature of the hot reservoir is 727 degrees Celsius, temperature, the first temperature of the hot reservoir, I'll write it as TH. Hot reservoir is TH, is 727 degrees Celsius, right? So convert it to Kelvin. 727 . So this will be 727 plus 273. So that will be 1000 Kelvin. You are supposed to find the temperature of the cold reservoir. TC is what we are supposed to find. Temperature for hot reservoir is given. Temperature for cold is what we are supposed to find. And efficiency is given as 75%. Yeah. So the temperature of cold is what we are supposed. So we use the formula which we have been known, that efficiency, the formula for efficiency, 1 minus Tc upon Th, 1 minus Tc upon Th. So 0.75 equal to 1 minus Tc divided by Th is 1000. So this first cross, yeah, first what do you do? Take this minus Tc upon 1000, take it over here. This will be 1 minus 0.75. I've taken Tc by 1000 to the left side, that will become positive. I've taken 0.75 to the right hand side, that will become negative. So Tc upon 1000 equal to 0.25. And when you multiply this, you get Tc equal to 0.25 into 1000. That is 250 Kelvin. That is your answer, 250 Kelvin. That's it. Next question is says a Carnot refrigerator operates between 250 Kelvin and 300 Kelvin. Calculate the coefficient of performance. Now we know that for a Carnot refrigerator, the coefficient of performance, that is COP. COP is the coefficient of performance denoted by capital K. The coefficient of performance denoted by capital K is given by the formula PC upon PH minus PC. This is our formula. So they have already given that it operates between 250 and 300. So TC is 300. So TC will be 300 Kelvin. I'm sorry. TC will be 250. TC will be 250 Kelvin. This is TH. Higher temperature will be higher value. So TH will be 300 Kelvin. TC will be 250 Kelvin. So substitute the values here. So 250 upon 300 minus 250. So this will be 250 divided by 50. That is 5. So the coefficient of performance is 5. That's it. An ideal gas is taken through an isothermal process. Students, please remember, isothermal process is a process in which temperature remains constant. Temperature does not change. The word iso means constant, thermal means temperature. So such a process in which the temperature is constant, that is called as an isothermal process, or we say change in temperature is zero. dt is change in temperature. Change in temperature zero hoga. Change in temperature zero hoga means final temperature and initial temperature both are same. Matlab temperature is constant, right? So if it does 2000 joule of work, yeah, one more thing you have to remember, whenever there is an isothermal process, the change in internal energy will always be zero. The change in an internal energy will always be zero whenever it is an isothermal process. So du will be zero. If it does 2000 joule of work, so work done is given, dw is given 2000. Then how much heat is added to it? dq you are supposed to find. Again, use first law. So dq equal to du plus dw. As I told you, du will be zero. So dq will be equal to 0 plus 2000. So that will be 2000 joule only. So change in heat or the heat added will be 2000. Very, 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 very important question. This is an important question. Ideal monoatomic gas. Regarding monoatomic, we have done in kinetic theory of gases. So for an ideal monoatomic gas, they have been already given. Whenever there is a monoatomic gas given, take gamma value as 5 by 3. Yeah, 1.66. Whenever there is a monoatomic gas given, gamma value is 5 by 3, 1 by 6, 1.66. It is adiabatically compressed. It is already given that it is adiabatically compressed. So adiabatic process may we have one formula, so that its final temperature is twice the initial temperature. So let T2 is 2 times of T1. T2 is the final temperature. Final temperature is twice the initial. What is the ratio of final pressure to initial pressure? Final pressure means P2, initial pressure is P1. P2 upon P1 ratio we are supposed to find. Whenever there is an adiabatic process and there is given in the data, it is given that is pressure and temperature is given to you, there is a relation. The relation says P raised to 1 minus gamma T raised to gamma is equal to constant. The relation is P raised to 1 minus gamma T raised to gamma is equal to constant. Now there are two things given. So we will let P1 raised to 1 minus gamma T1 raised to gamma equal to P2 raised to 1 minus gamma T2 raised to gamma. From here I will find out P2 upon P1. P2 upon P1 raised to 1 minus gamma common. That will be equal to T1 upon T2 raised to gamma. I'm just rearranging the term. I'll not put the value. First you rearrange the term, then you put the value. So now I have rearranged the term. Now there is nothing to be rearranged. Now you put the value. So P2 by P1 raised to 1 minus gamma. That will be equal to T1 upon T2 raised to 1 minus. So this will be P2 by P1 raised to 1 minus 5 by 3 equal to T1 upon T2 is 2T1 raised to 5 by 3. So T1 getting cancelled. So here I am left out with what? P2 upon P1 raised to 1 minus 5 by 3 will be minus 2 by 3. That will be equal to 1 by 2 raised to 5 by 3. I need to find P2 by P1. So multiplied by minus 3 by 2. So P2 by P1 power multiplied by minus 3 by 2. So this will be 1 by 2 raised to 5 by 3 into minus 3 by 2. I said I need to reverse this power and multiply so that this power will get cancelled. Are you understanding? Why did I multiply by the minus 3 by 2? I need to cancel out this power because I just need P2 by P1. The question is only asking P2 by P1. There is no power here. So I need to remove this power. So to remove this power, I multiply by the reverse of that power, that is 3. So 3 will get cancelled. So P2 by P1 will be equal to 1 by 2 raised to minus 5 by 2. So this is minus here. There is minus sign here. Minus 5 by 2. So when you see this, so this will be, when you reverse this will be 2 raised to 5 by 2. When I become minus 5 by 2, 1 by 2 raised to minus 5 by 2, I'll take the reciprocal. When I take reciprocal, negative power will become positive. So 2 raised to 5 by 2. And 2 raised to 5 by 2, that means square root of 32. 2 raised to 5. 2 raised to 5 is 32. Square root of 32 is 5.6. That is your answer. Hypothetical thermodynamic cycle is shown in the given figure. So I'll just draw one given figure. They have been given in the question. There is a question which is given. The pressure and volume is given to you. This is the pressure. This is a volume. There is a cycle over here in between, and this value is 11. This value is 1. For volume, this value is 2, and this value is 6. Volume is in 10 raised to minus 3 and 10 raised to 5 Pascal into 10 raised to 5 Pascal into 10 raised to 3 meter cube. 10 raised to minus 3 meter cube. Calculate the work done in 25 cycles. First, let us calculate the work done for one cycle. Whenever there is a circular shape given, always remember, whenever there is a circular shape given, the work done for circular shape, work done for this process. Now, this process means the circular shape. It depends on the shape. If the shape changes, the work done formula changes. Work done is basically the area of that particular shape which is given to you. Now, here which shape do we have? We have circle. So, area of the circle. So, work done for this process will be equal to, there is a direct formula I will give you in case of a circle. For case of a circle, pressure into volume, there is a direct formula. Whenever there is a pressure and volume given, it is given by pi by 4 P2 minus P1 and V2 minus V1. This is our formula. So W will be equal to, this is the formula, pi by 4 P2 minus P1, V2 minus V1. This is for one cycle. So if it is for 25 cycles, so W will be equal to 25 into pi by 4 into P2 minus P1 into V2 minus V1. Now just put the value and solve. That's it. 25, 3.14 upon 4. P2 value is the higher value. So that is 11 minus P1 value is 1. The common variable is 10 raised to 5. V2 minus V1, 6 minus 2 from the graph. The common variable is 10 raised to minus 3. So when you solve this, on solving this, you get the answer as 7.84 into 10 raised to 4 joule. That is your answer. So this is the formula you'll have to remember for this particular shape. For the circle shape, you'll have to remember the formula. A system is to be taken from a hypothetical path is given in the question. So if you see the work done, again, if you see the diagram very carefully, the work done, there is a square. Now in square, what will you do? The question is asking find the work done in each case. In each case means each path you have to find the work done. The question in the previous one was asking find the total work done directly. So you will take area. Whenever there is a work done for each case, you will individually solve for each case. This is A, this is B, this is C, this is D. This is given to you. And the values are 2. Here it is 6 and volume is in liters. Here is pressure with volume 2 over here, volume 6 over here, and 10 raised to 5 is your common variable over here. So in each case means work done for AB, work done for BC, work done for CD, work done for DA, all four cases. If you see very carefully, work done for BC and work done for AD, yeah, DA, whatever I say, will be zero. Why zero? The reason you will have to write, the volume is constant. The volume is constant. Why the volume is constant? If you see in the graph, the volume line is not changing. It is always 6. Entire the path BC, for entire path BC, the volume is 6. It will not change from B to C. Same case for D2A. D2A also the volume is remaining fixed. It is not changing. It is 2. So the volume is constant, work done is 0. Because the work done formula is pressure into change in volume. The work done formula is pressure into change in volume. So the work done for first case AB. In case of AB, the pressure is 6 into 10 raised to 5. The change in volume will be 6 minus 2. That is 4 into 10 raised to minus 3. What is this 10 raised to minus 3? I repeat once again, liters. I have converted liters to meter cube. How did I get 4? A to B, na? A to B. If you see the area, if you see the point for A on x-axis, it is 2, and point for B on x-axis is 6. I need to find the change in volume. Change in volume means final minus initial. So final minus initial matlab B minus A. So B minus A कितना होगा? 6 minus 2. 6 minus 2 is 4. So 6 4s are 24. So 24 into 10 raised to 5 minus 3 is minus 2. Sorry, plus 2 joule. This is your answer. Maybe in some books the answer is incorrect, but this is your correct answer. Work done from C to D. This will be equal to, again, the pressure for C to D path. If you see, it is below 2 into 10 raised to 5. And the volume, if you see over here, again, volume will remain same, 6 and 2. There are two things only, 6 and 2. So 4 into 10 raised to minus 3. But here, initial will be 6, final will be 2. Okay, initially 6, final is 2, so minus 4, because it is compressing, right? The volume is decreasing, so it is minus 4. So this will be minus 8 into 10 raised to 2 joule. That's it. This is your answer. So work done for BC and DA is 0. AB and CD is what we have calculated for each individual case. So this one was your question, which was given to you. There is one sum which I have skipped over here. That is sum number 11, which is showing a graph. So if you see that graph very carefully, the answer itself is given in the question. The one question is given to you with the PV curve. Sorry, VT curve is given to you in the question. For diagram, you are supposed to draw the PV curve and PT curve. So in textbook itself, they have given the answer.